Part A, represent this information on a Venn diagram. Okay, so we have information here about 100 students that were asked which pet they like from a choice of cats, dogs, and hamsters. So this will create a 3-set Venn diagram. The first set, and when I say set, I mean these circles here. So the first set here, C, represents the students that like cats. The second set, D, students who like dogs, and then the third set, C, those who like hamsters. Now, the important concept to understand when you're filling out a Venn diagram from information is to always start from the inside and work your way outwards. And the reason for that is, if I look at this first piece of information that 60 student likes cats, if I just started with that, and let's say I go back to this cat circle here, the question that I pose to you is, whereabouts would I put that 60? Because of these 60, of the 60, there could be a group of students that like multiple pets, and that would be contained in the intersecting regions. So I wouldn't know where to put this 60. And if I just put the 60 out here somewhere, I would be double counting students later on when I go to fill out these intersection regions. So in summary, let's work from the inside of the Venn diagram, which the innermost region is this intersection here, which represents the students who like all 3 animals, and we'll work our way outwards. Okay, so let's work through this. The bottom line here gives me that piece of information. So 32 students liked all 3, cats, dogs, and hamsters. So I can confidently go ahead and place 32 in this middle intersection here, which represents the students that like all 3 animals. Okay, so that's that piece of information there done. Let's now work through the pieces of information that involve 2 pets. So I'll start with this one here, 34 like cats and dogs. Well, cats and dogs is this region here. All the numbers within this region need to add up to 34. Now, we already have 32 in this middle intersection, so therefore this remaining number here has to be 2, because 2 plus 32 is 34. So that is that piece of information complete. Let's now look at the next one. 46 students like dogs and hamsters. Dogs and hamsters will be this intersecting region here. Now, these 2 numbers need to add up to the total to be 46. Now, we already had this 32 here. That was the first number we put in place. So in order to find this number here, I was thinking, well, what number plus 32 will equal 46? Or another way to calculate that is 46 subtract 32, and that is 14. So what this 14 here means is the number of students who like dogs and hamsters, but not cats. That's what that 14 here means. Similar process for the 43 who likes cats and hamsters. So let's just talk that through. Cats and hamsters is this region here. We already had 32. The 2 numbers need to add up to 43. So that's where this 11 comes from. 11 plus 32 is equal to 43. Okay, so all of the regions now that involve liking multiple animals, either 2 or this middle 3 here, are now complete. Let's now work through the information of people that like only one type of animal. So let's have a look at this here. 60 like cats. So the whole cat set is this circle here. Now, all of these numbers here need to add up to 60, because these represent all of the people that like cats, including those people that like cats and other animals. So all of these numbers here need to add up to 60. Now, we already had the 2, the 32, and the 11 from prior parts. So the way that I like to think about this is, okay, I know my total needs to be 60. So I'm going to subtract away the 2. I'm going to subtract away the 32, and I'm going to subtract away the 11, and that leaves 15. So 15 students like cats, but not any other animal. Now, I did that same strategy for dogs and hamsters. So at that point in time now, I now have all the areas of the Venn diagram within the cats, dogs, and hamsters set complete. However, I'm not quite complete yet, as I need to quickly check, were there any students that didn't like any of these types of animals? Now, I know that we had 100 students surveyed in total, so I added up all of the numbers inside of the circles. So let's just quickly go ahead and do that. So I hit enter there, I get 94. So far I have counted 94 students. They were the students that like some type of at least one of these three types of animals. However, I surveyed 100 in total, so therefore that leaves a remainder here of 6. These 6 students didn't like any of these three types of animals. Perhaps they liked other types of animals, maybe horses or whatever, or maybe they didn't like animals in general. But these 6 here didn't like these three types of animals. Okay, that is our completed Venn diagram. Part B has 3 parts. Let's work through them one by one. First part, find the number of students who like dogs only. Okay, if we look at our initial Venn diagram here, this is the dog set. So all the students who say they like dogs. But this dog set here is made up of 4 parts. We have this 2 here, which represents the students who like dogs and cats but not hamsters. We have the 32 that like all 3 animals. We have the 14 that like dogs and hamsters but not cats. And then we have this 16 here, which represents the number of students who like dogs, but they didn't like cats and hamsters, or hamsters. So our answer here for the first part, and this is shown in this light green shading here, we have 16 students that like dogs only. Okay, let's now talk about the second part of B. Find the number of students who like both dogs and cats, but not hamsters. Okay, let's circle the dogs and cats region. The dogs and cats. So this is the whole dog set. This is the whole cat set. So dogs and cats will be this part here. But we don't want to include the students who like hamsters. We don't want to include those who do not like... Sorry, I got myself a bit confused there. Just rereading the question. Like both dogs and cats, but not hamsters. So in this region that I have circled here, I'm including this 32 that are part of the hamster set. So therefore, these 32 here do like hamsters, so I don't want to include them. So I'll leave just this. So what remains here is just these 2 students who like cats and dogs, but they do not like hamsters. So if we look at the solution here, you can see that I have shaded that region. So this 2 represents cats and dogs, but not hamsters, and that is the answer to the second part of B. Now the final part of B, fairly easy one here if you manage to draw the Venn diagram correctly in part A. Find the number of students who do not like pets. Well, it's a bit of an assumption here in this question because I would probably clarify this question to say that do not like cats, dogs, and hamsters. Because this 6 here that represents those students that don't like these 3 animals, they could like another type of pet. They could like turtles or goldfish or horses. So not a great question, this one, but we need to assume here that they are referring to these 3 animals, cats, dogs, and hamsters. So therefore, the answer to the third part will be these 6 that sit outside of the cats, dogs, and hamsters sets. Let's have a look at the answer here. The region shaded, the light green, represents those who don't like any of the pets. That is 6, and that is the answer to the third part of B. Part C, a student is randomly chosen from this group of 100 students. So let's say all 100 students was in a large classroom or maybe a sports arena, and we were randomly choosing one of these students out of the 100. Calculate the probability that this student likes only 2 kinds of pets. Okay, so looking at our original Venn diagram here, the regions that involve students that like 2 only, so not 3, I have shaded in light green here in this second Venn diagram. So this 2 here represents the 2 students who like cats and dogs but not hamsters, so 2 types. These 11 students here represent the students who like cats and hamsters but not dogs, so again 2 types. And this 14 here represent the students that like hamsters and dogs but not cats. So these 3 green region here are the students who like only 2, and they are what we would call our favourable outcomes in our probability calculation. So our favourable outcomes is the sum or adding up these 3 regions here, so 2, 14, and 11, divided by the total number of possible outcomes, which is all 100 students. And if we enter this into our calculator, we get an end result, a probability of 0.27. So the probability selecting a random student out of the total of 100 that like exactly 2 will be about 27%. Part D. Again, a student is randomly chosen from this group of 100, and we are asked, calculate the probability that this student likes only dogs, so not cats or hamsters, given that this student only likes one kind of pet. Okay, so when we see given here, this is usually a sign that it is a conditional probability question, which is the case. However, if you do draw a good diagram, in this case here a Venn diagram from part A, or in tree diagram questions as well, you can actually solve these questions without using the conditional probability formula. You can do it just by looking at the diagram and, in this case here for a Venn diagram, shading the regions. So I'm going to talk about that strategy first, and then after that I'll talk through the conditional probability formula here. Okay, so calculate the probability out of this 100. The student likes only dogs. So only dogs is this 16 students here, given that this student only likes one kind of pet. Okay, so out of the 100, I'm not going to now take into consideration all 100. I'm actually going to take into consideration only those that like one type of pet. And they are this 16, this 15, and this 4. So my total number of students that I'm actually going to be selecting one from is actually going to be 16 plus 15 plus 4. And what I'm being asked is, out of the, let's just quickly calculate what that is, 31, 35. So that is 35 students here that I'm now selecting one out from. And the question says, okay, out of this 35, what is the probability that these students like dogs? And that'll be this, and that'll be the favorable outcomes, these 16 dogs. So my numerator here will be 16. So you can see here that I managed to solve this without actually using the conditional probability formula, just by accurately selecting the regions on the Venn diagram. Okay, let's now talk about the conditional probability formula approach to this. It's kind of very similar, but it's good to talk through the formula here. So this formula here is in the AI formula booklet. It reads the probability of event A given event B, and that is equal to the intersection, or the probability of the intersection of the two events divided by the probability of the given event. Now, if we convert this into the context of our question, it says the probability of a student liking dogs given that they only like one kind. And that will equal, on the numerator here, the probability of dogs and only liking one kind. So that will be dogs and only one kind. So 16 out of a total of 100. So 16 on 100. That's the probability of dogs and only one kind, divided by the probability of only one kind. And that is the addition of 15, 16, and 4 out of a total of 100. So this here is actually going to be 4 over 100. Now I have a fraction on a fraction where the denominator is the same. So you can actually cancel the two denominators out. And the reason for that is 16 on 100. If I write this like this instead, let's say, and 16 plus 15 plus 4 is 35 on 100. You may have seen or know that if you have a fraction divided by a fraction, you can actually rewrite it as a multiplication and have the reciprocal of the second fraction, or flip the second fraction. And then if we cancel common factors on the top and bottom, the hundreds actually cancel, and then I end up with just 16 on 35, which is the same as kind of just knowing shorthand that if we have a fraction on a fraction, the two denominators cancel out, just leaving 16 over 35. That's this line here. And look at that, that actually lines up with what we did just visually earlier on, but either strategy is fine, but we end up with a final answer of, rounded to 3 sig fig, 0.457.